Today, I'm gonna help you shift your mindset from software engineer to machine learning. And I know in the last video, I said that we were gonna get our hands dirty, but I feel like this shift in thinking is so important that we kind of need to talk about it first. Before you can fully learn machine learning, you need to let go of the few things that are hardwired into your brain as a dev. So, lesson one, you need to let go of control. As a dev, you're used to controlling every line of code, every behavior of your application. There's a bug in your code. What do? You step through the code and fix the exact line that doesn't work. That is to say, given an input, you define the rules and you get an output based on those rules. The input and the rules box belong to you. You directly and explicitly control this through code. You are paid to make sure that these two boxes are the best that it can be, so that the output, which you don't directly control, behaves as designed. Just to reiterate, you don't directly control the output. You control the rules, which will then create the output. Let's take a look at how this works with some code. Let's say we have a function, add 100 with a single input. Your input is this num parameter, and your rules is this one line of code that will add 100 to the num parameter. So let's say our input num values are 1, 2, and 3, and so on and so forth. You would get 101, 102, 103, and so on and so forth. This is very clear and you can control the behavior explicitly. You can change the 100 to something else, which will technically be introducing a bug in your code, or you can add another parameter, maybe num2. The point is you can directly change the rules to affect the output. So then, what is different in machine learning? Watch this carefully. Did you see that? Let me replay it again, okay? What is different in machine learning? Your rules box and your output box have actually been swapped. You have control of the input like before, but you no longer control the rules. Instead, you control the output. And right now you're probably like, oh my God, what the F? What does that even mean? This is the first step of confusion for many devs getting into machine learning. All of our tooling, all of our workflows, everything we've known has to do with controlling, maintaining, and observing code. If you're the type that needs all of this, or you need to be able to explain things when things happen or when something doesn't work, you're not gonna have a good time with machine learning. Here's a scenario. When your boss comes to you and say, hey, when is the model going to become better? When can we launch to our users? You won't have an answer to that. You cannot control the model with the amount of granularity as you're used to as a dev. It's effectively a black box. Just let go of this rules box, your life will be a lot easier. So now you're thinking, we don't control the rules, we control the output. What does that even mean? Let's change out the diagram so that it's a little bit easier to see and maybe easier for me to explain. You define your input and your output as a pair together. You need to feed this into your model. Some magic's gonna happen, and then it's gonna create its own rules. What's an input and an output? Think about how you learned growing up. How did you learn a dog was a dog? Well, somebody probably pointed to an animal, the input, and said that it was a dog, the output. They did this across a bunch of different dog breeds, and eventually you figured out the pattern or you memorized it. This is exactly how machine learning works, at least in a neural network, which will be the core focus for this video series. How does it work like this? Because math. Don't worry about the details for now. Treat it as a black box. We'll get into the details later. Let's take a look at how our add 100 function would work here. Your input remains the same. You can define a single input of an integer called num. Your output has to be 101 because the goal of the model is to add 100. This is one data point. One data point that you've given a model, and this is far from enough. You need a lot more data. Like a lot more. In a function like add 100, you can programmatically generate this. And if you can do that, just use the code. You don't need machine learning. But in the real world with more complex problems, you need to mine the data and then clean it up. The easiest way to do this is to have an already existing app and collect the user behavior. Once you have this, this is known as your data set. With your data set, you can do some machine learning magic and have your model create its own rules. What's another word for this? Weights. So if you ever see people on the internet say something like the weights need to be open source or the weights need to be released, this is exactly what they mean. And once again, it has to do with math, so we'll talk about it later. So now you might be wondering, why go through all this work just to create a model that will add 100 to a number? You're right. You should not go through all this work to do something so simple. Even though you can train a model to do pretty much anything, not all things should be done with machine learning. In fact, the rule of thumb is that if you can simply write the code, then choose to write the code. Machine learning should only be used for far more complex features of your app, say a recommendation system or a translation feature. For these tasks, you could write all the rules by yourself, but it would be super hard and it would take forever. Just think about writing all the code to deal with a translation system from English to Chinese. You would have to write every single rule and cover every single edge case. And it would be a nightmare to maintain because you know how the kids like to come up with new lingo nowadays. So if machine learning is so challenging to get right, why do it? Well, you need to have a bit of a fundamental shift in thinking. You are giving up control for insight. You directly control your function's rules through code. You directly control your model's rules through data. Let's say you have a fairly complex set of custom behavior that can happen. The easiest way to spot this is if your function has a bunch of nested if statements or a large switch case that branches pretty deep. To add new or remove old behavior, you need to define the requirements of that feature so you can code it up, which means you need to be aware of all the conditions and edge cases. You're going to be wasting a lot of time writing and maintaining that code. With machine learning, you throw your data at the model and it will essentially learn the requirements and the edge cases. The model can then discover things that you didn't even think or even plan for. This is the insight that you're getting when you're giving up your control. This is why machine learning is so powerful. A model can see patterns that humans can't easily see, so it can create rules that we're not even aware should even be created. This is the first fundamental shift in thinking that I personally needed before I was able to learn machine learning as a dev. So in this video series, here's what we're gonna do. We're going to start off with a data set, and I'll choose this data set so that we're not starting from different data points and nothing is misaligned. Then we're going to naively use that data set to train the worst model you'll ever train in your life. We're going to improve it little by little. And as we do that, we're going to learn things step by step in bite-sized applicable pieces. Maybe one day we'll learn an analysis technique, maybe another day we'll learn some technical term, or maybe we'll even learn a bit of math. By the end of all this, you're going to be able to go from data to a trained model and know exactly how to use that in production. This is exactly what I will help you do. Starting in the next video. See ya!